Good morning children, this is Hemlatha. Welcome to class 7 IIT physics class. Children, what we are doing, we are discussing about the laws of motion. Newton's laws of motion, very important, famous. Okay, Newton's laws of motion. We already completed Newton's first law of motion. What is Newton's first law of motion? According to Newton's first law of motion, if a body is in rest, it continues in rest. Okay, take one book, keep it on a table, watch it, observe it for some time. You will see there will not be any movement in the book by itself. Is it? Unless you are not applying any force to move the book from its place. So if a body is in rest, it continues in rest. Or if a body is in motion, it continues in motion unless an external force is not applied to stop it or change its direction. That is Newton's first law of motion, and we also saw some consequences also based on first law of motion. Clear? Now we will move on for Newton's second law of motion. But before going to start Newton's second law of motion, there are some important topics we must discuss. You must know about that topics. So that one we will have to discuss first. In that is the main topic is linear momentum. So today's class is based on linear momentum. Okay children. So let's start today's class. Okay. See children, suppose there are two bodies. Okay, these are the two bodies. First body is having mass m1 and second body is mass m2. It means two bodies of different masses. Is it no? Two bodies of different masses, m1, m2. What is given? m2 is greater than m1, means second body is heavier than first body. Okay, there are two bodies of different masses, m1, m2, and second body is heavier than first body. Both the bodies are moving with same velocity. You can see here what is given, v, same given. v means both the bodies of different masses but moves with same velocity for same time t. Clear children? I hope you are understanding. There are two bodies of different masses, m1, m2. Second body is heavier than first body. Both the bodies are moving with same velocity and in same time. Okay. Then the force required to stop the bodies. Are the forces same? Think it. You have to apply some force to stop the body. Body is moving with same velocity v. You have to apply some force to stop the body. No? What is Newton's first law says? If a body is in motion, it continues in motion unless an external force not applied to stop it. So you have to apply some force to stop it. So let the first force be F1 to stop the first body and second force is F2 to stop the second body. Then which force is more? Of course, the second force F2 is greater than F1. Force to stop heavier body will be more than the lighter body. Okay, first body is lighter than second body. Second body is heavier. Both are moving with same velocity. Then more force is required to stop heavy body than lighter body. This is a case 1. Understood children? Case 2. Let us consider case 2. Again two bodies are there. But this time both the bodies are of same masses. See, m1, 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 m1. Both the bodies are of same mass, but both are moving with different velocity. first is moving with v1 velocity, second is moving with v2 velocity. Okay, now v2 is greater than v1, means second body is moving faster than first body. The velocity of second body is more than the velocity of first body, means second body is moving faster than first body. Clear children? Understanding? Two bodies of same mass, but both are moving with different velocity. First is moving with v1, second is moving with v2. Second is moving faster than first body. Both in the time t stopped. Now how much force applied to stop these bodies? This time also, will the forces same? No. Once again, force to stop these moving bodies will not be same. Of course, masses are same, but velocities are different. So, force required to stop a faster body will be more than slower body. Got it? So, from both the cases, children, what you observe? Force required to stop a heavy body also more, and force required to stop faster bodies also more. Okay, so force needed to stop a moving body in a definite time depends both on mass of the body and velocity of the body. Force required to stop a moving body depend on mass also and velocity also. Clear children? Please note down this first. Take your notes, okay, and give the subject, date, time, today's topic, linear momentum, and draw this neatly. Children, you must maintain your notes neatly write down, draw this, and you must pause the video when you are writing. Pause the video and write down. After writing only you can continue the video, because I can't focus the paper for more time. If I will do so, the video length will increase. That's why whenever I am focusing, you must pause the video and write down. After writing only again you continue the video. Okay? So next is linear momentum of a body is what? It's a product of its mass and velocity. Whenever a body is moving, okay, its linear momentum is nothing but the product of its mass and velocity. Okay, so what is the formula for linear momentum? Let us consider a body whose mass is m and moving with velocity v, then its linear momentum is p. Okay children, linear momentum is denoted by the symbol small p. Remember, linear momentum is denoted by a symbol small p. Small p is equal to m into v, product of mass and velocity. Okay, now what is its nature? Momentum. Momentum is a vector quantity. It is which type of quantity? Vector quantity. Vector quantity means it is not only having magnitude, it is also having direction. So what is the direction of momentum? So the direction of momentum is along the motion of the body. Means body is moving in which direction? That is only the direction of momentum. Momentum is what is the formula for momentum? Small p, linear momentum is equal to product of mass and velocity, m into v. and it is which type quantity? A vector quantity. As it is a vector quantity, what is its direction? Its direction is along the motion of the body. Body is moving in which direction? In that direction only momentum. Next is units. What are the units for momentum? So children, now only we discussed momentum is equal to mass into velocity. Now what is the SI unit of mass? SI unit of mass is kilogram and SI unit of velocity is meter per second. So kilogram into meter per second is what? SI unit of momentum. So SI unit of momentum is kilogram meter per second. Just like that, P is equal to the CGS unit of mass is what? Gram. And CGS unit of velocity is what? Centimeter per second. So what is the CGS unit of momentum? Gram centimeter per second. Okay children, please note down this. Okay. Now next topic is change in momentum. Change. Okay, so change in momentum. So delta P is equal to mv. M into delta V. Change in momentum. So change. Delta stand for, this is a symbol for delta. Okay, a triangular sign, delta. Delta stands for change, a small change in quantity. So now we will study change in momentum. Delta P means change in momentum. P stands for momentum, delta stands for change. So change in momentum is equal to delta mv. Delta means change in mass into velocity. Now, how this change in momentum comes? What is responsible for change in momentum? So many factors can change the momentum. Is it no? So momentum is equal to product of mass and velocity. So if mass changes, momentum will change. Is it or not? Change in mass is possible for change in momentum. Next is change in velocity. If velocity of the body is changing, then also momentum can change. Or change in both mass and velocity. If both is changing, mass and velocity, both is changing for a particle, then also momentum will change. Is it or not? Momentum P is equal to mv. Now if mass changes, momentum will change. Velocity changes, then also momentum will change. Or mass and velocity both changes, then also momentum will change. So delta P means change in momentum is equal to delta mv. Now children, mass if constant, then what is changing? Velocity is changing, then only momentum change. If both is constant, then momentum can't change, no? Is it? Momentum is changing means either mass is changing or velocity is changing or both is changing. Suppose mass is constant. If mass is constant, then of course velocity is changing. Then how to write? M delta V. We know children, mass is a constant quantity. Mass of a particle is not changed. Whenever a particle is moving, okay, some distance, changing its velocity, but mass is not changing. Mass is a constant quantity. But there are still some cases where mass of the particle is changing. Example, rocket. You know rocket? So in rocket motion, the mass of rocket decrease. decreases as the burnt gases expel out of the nozzle. Is it? I think you all of you saw when the rocket is going up. So in the rocket motion, when the rocket is going up, okay, it releases a very high amount of gases, burnt gases expel out of the nozzle. Is it? And when these gases are expelled out of the nozzle, okay, that time what happened? Mass is decreasing. Okay, so in this case mass changes or not? So mass does not remain constant in all the time. There are some cases where mass also changes. So this is one of the case. Now next we will discuss, I hope you have written this, write down. Once again pause the video, write down, after writing only again continue the video. Okay, now we will go for the next topic, rate of change of momentum. How the momentum is changing. Rate of change of momentum. When a force is applied on a moving body, its velocity changes. Is it true? Yes or no? A ball rolling on ground. When you will kick the ball in the same direction, then what you are doing if you are kicking the ball? You are applying the force. So when you will apply the force on that moving ball, what happens? Its velocity increases or not? Of course changes its velocity increases. So due to change in velocity of the body, momentum also changes. Now only we discussed momentum. Linear momentum of a body is equal to product of mass and velocity. Momentum changes, which cases? Mass of the body changes or velocity changes or both changes, mass and velocity both changes, then also momentum changes. Now if you will apply force on the moving body, its velocity will change compulsory, no, it will move again faster. Velocity changes means momentum changes. So let a force F, okay, there is a force F acting on a body of mass M. How much force? F force is acting on the body whose mass is M, and for what time? T time, due to which its velocity changes from U to V. There is a body whose mass is M. Okay, it is moving, and for time t its velocity changes from u to v, initial velocity to final velocity. And what is the reason in change in velocity? F force is acting on the body. You applied force, F force on the body, so its velocity changed from u to v. So what is the initial momentum of the body? Initially the momentum of the body is mass into velocity, m into initial velocity, mu. Final momentum of the body, so final momentum, mass into velocity, m into v. V is a final velocity, u is the initial velocity. Mu is the initial momentum, mv is the final momentum. Clear? Change in momentum of a body in what? T second. We know, children, change how to calculate? Change always equal to final minus initial. So final momentum mv minus initial momentum mu. So change in momentum of the body in time t second equal to mv minus mu. Now particle is same, body is same, so its mass is also same. Of course you applied force F and its velocity changes, but mass remains constant. is it? So mass we will take constant common, then what is left? M into V minus U. So rate of change of momentum. Rate, how to find rate? Rate of change of momentum is equal to change in momentum by time. Rate, how to find? Rate of change of momentum equal to change in momentum by time. What is change in momentum? Now only we calculated M into V minus U by time t. Now we know already acceleration is equal to, what is the formula? Change in velocity by time. Acceleration is equal to A is equal to V minus U by T. Okay, so this V minus U by T is replaced by A. We know acceleration means what? Acceleration is change in velocity by time. A is equal to V minus U by T. Now this value of A is substituted here. Here what we got? Rate of change of momentum. Change in momentum. M into V minus U by T. Now V minus U by T is equal to A. So M into A. MA. So rate of change of momentum is equal to mass into acceleration. So what we concluded? What is the conclusion? Whenever a force acts on a body, the rate of change of momentum of the body is equal to product of mass of the body and acceleration produced in it due to that force. Whenever you will apply force on a body, its velocity changes. Velocity changes, momentum changes. So the rate of change of momentum, how to find out, is equal to product of mass of the body and acceleration produced by the body due to that force. Acceleration, how acceleration will produce? When you will apply force. So acceleration produced due to what? Due to the force applied on the body. So please write down, children, this one. I hope previous one you have written. Okay, again and again I am saying, children, when you are writing, please pause the video and write. After writing only you again continue the video. Okay, so this is for today. Today what we discussed? We discussed about linear momentum, nature, formula, units, and then change in momentum, and then rate of change of momentum. This is very important topic before starting the Newton's second law of motion. Clear, children? So again I am telling you, you have to watch the video till end and minimum 2 to 3 times completely, then only you can understand it. Okay, and today what we discussed, once again you have to practice it in the notes 2-3 times, then only you can understand this, children. Okay, this is for today. Thanks for watching.